82. This one is on evaluating functions and then domain and range. Okay, so for example, if I were to say, if f of x, function of x, is x squared plus x minus 10, and then it says this, find the function of 5. Now, this function of x means find the function of
So you
5.
just insert 5 into that.
So you insert the 5 where you see an x. And so wherever where I see an x, I'm going to put parentheses. And it's important that you do this. I'm going to make that plus negative. Because a lot of times it just makes a difference. So go on and put parentheses around that. And so I'm going to put a 5 every time I see an x. Okay? Now 5 times 5 is 25 plus 5 plus a negative 10. So equals 30 plus a negative 10 equals 20. So when f is 5, the answer is going to be 20. Pretty simple.
Yep.
Okay, and I can put anything in there. If f is 7, then it will equal, whatever it is. I haven't actually done it. But basically, they're going to tell you if the function of x is, and then they'll tell you what x is over here. Okay, so it's not real hard. Let's try another one. Sometimes it's not going to make as much sense because they're going to be letters instead of numbers. That always gets confusing. For example, here's a letter one. If, and now this time they do h of x, still the same kind of thing. If h of x equals x squared plus x plus 1, then it says find h, and then it puts this a squared. Okay. This is basically h, that's just a different letter instead of f for function. So basically we're finding the function of x, and our x is what we're going to put in there is a squared. So again, put your parentheses, and everywhere you see an x, you're going to put a squared. So a squared squared. Don't let that trick you, because the x is a squared. So we put a squared in this spot, and then that is squared. Plus a squared plus 1. Stay with me? Okay? And then a squared, that twice, remember those add, the exponents add. So it's a to the 4th plus a to the 2nd plus 1. So you just write, that's what they're wanting you to find. So you put h, a squared equals. So when our x or our h is a squared, this is going to be your answer.
Would you not add the a fourth next to it?
Nope, because if we were multiplying, we could go a6. But remember, in math, when you have, there are different terms, like monkeys, dogs.
Oh, yeah, that's right. Okay.
When you're adding, see how they're adding?
Yeah.
If this was a multiplying problem, then it would be a to the 6th.
Yeah.
But adding, they're like seen as two different, this is male, female,
I got you.
dog, cat, whatever, okay? So it's hard to remember that rule, but it's very important that you do. Okay, let's do another one. Here we go. If f of x equals x squared plus 1, and then it says this, find f of x plus 2. So basically what that means is this f of x is x plus 2. So I'm going to put a parentheses there. So everywhere I see this x, I'm going to put that inside of it. X plus 2 squared.
Plus 1.
Plus 1. Okay? So now this means x plus 2 times x plus 2. That's what x plus 2 squared is. Plus 1. Bringing that down. Okay? So now x times x makes x squared.
Plus 4.
X times 2 makes 2x. 2 times x makes 2x. 2 times 2 makes 4. Okay? Plus 1. Plus 1. Okay? This is something, x squared, this is like dog. 2 cats, 4 of whatever, and 1 of whatever. Okay? So I'm going to put all the x squares with 1 line, all the x's 2 lines, and all the numbers 3 lines. And now you're adding like terms. So x squared just comes down. 2 dogs plus 2 dogs makes 4 dogs. Plus 4 elephants plus 1 elephant makes 5. That, so f of x equals that.
Yeah.
So whatever your thing is, that's what you solve for. I actually need to write f of, yeah, that's what I thought. Whatever it says find this, then you write this, and then you show me what the answer is when you had this as your x, so to speak. Understand? So this is be like y equals da 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 da. Well, they told us to find this. Instead of find y, find this. So we put this here. So it almost be like y equals this. Got it? Alright, now moving on to domain and range. And this is kind of hard to understand, but I just want you to stay with me, okay? So the first thing I want you to notice is domain. I want to write this down. Domain and range. Okay? Domain and range. Domain is all possible x values. I'm going to explain to you what I mean by that in a minute. Range is all possible y values. Okay? And this is talking about an x, y, we're going to do a chart. Okay? So now that you know what domain and range are, here's what it says. If f of x equals 2x, and it says this, find the domain and range of the function f. Of the function f. Okay. If f of x is 2x, find the domain and range of the function f. Okay. Remember, domain means what?
It's the possible values.
All x values. And range means?
All possible values for y.
All y values. Okay. Now, when I looked over this, and I even watched a video on it, when you look at this, you know how when you see y equals 2x plus 4, and you were able to graph it by putting the 4 and then going up and down 2 or whatever? This one is saying, okay, because we don't know what the y-intercept is, 4, then we just should assume that it's 0. This is just what he said. I'm going to show you another way that I have figured it out that makes a little bit more sense, but let's just presume this is what he's saying. 2x plus 4, we would know to graph 4, right? And then go up 2 over 1, because this is really 2 over 1. Okay, but because we don't know our y-intercept, we should assume it's 0, is basically what he's told us to do. Okay, so I'm going to assume that it's 0. 0. 0 up, 0 over, just 0. And now our slope is 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And as you can see, that is what we're making. Okay? Now, basically they're asking us then, if they're wanting us to find the domain means all the x values. Well, if I kept going on and on and on and on and on and on, then all my x's literally could keep going on and on. 1, 2, 3, 4, 5, 6. These are all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And same thing on the left. -1, -2, -3, going all the way. And it literally, I could go up 2 over 1, up 2 over 1 for my whole life. So what does that tell me? That what is my domain? My domain is all the numbers on the x value. Okay? What is my range? Well, this is my y, which is my x value, or my y is my range. So I can literally keep going on and on and on. So guess what? I can always go up 2 over 1, up 2 over 1. And what's that going to do? It's going to use up all my y forever. Or if I go down 2 over 1, down 2 over 1, I'm going to use up all my y. So what does this tell me? Find the domain and range of the function. Basically what you're going to say is it's all real numbers. Meaning there's no specification. It doesn't stop anywhere. It keeps going. It's real numbers forever. It's going to keep going this way. It's going to keep going this way. So we're always going to have your real numbers.
Yeah.
You got it?
Mm-hmm.
Okay. So what is my domain? All real numbers. What is my range? All real numbers. Got it?
Mm-hmm.
And the way they do it is they put it in this little thing. Okay? And it just says all real numbers.
Yeah.
That's just showing you that the domain includes
So
all
that
real
would be the
numbers.
answer.
That this would be the answer.
Okay.
Okay, but the graph kind of helps us see better. Okay? Another way that I have learned to do this.
If they ask that question, do we need to graph it if we already know?
No, you don't have to.
So we already know it's all real numbers. If they ask you that specific question.
Well, we didn't know it was until we graphed it.
That's true, yeah.
It helped. Okay, another way that helps me is to see this right here as a y.
Yeah.
Y equals 2x. Okay? We go by that system. Then if my x is a 1, then what is my y answer? A 2. If my x is a 2, then what is my y answer? A 4. See what I'm doing?
Yeah.
If x is 1,
Yeah.
then 1 times 2 is 2, so y is 2. If x is 2, 2 times 2 is 4, so my y is 4. If x is 3,
It's gonna be 6.
it's going to be 6. Okay, let's do a negative number. If x is negative 1,
It's gonna be -2.
negative 2. If x is negative 3,
It's gonna be -6.
it's going to be negative 6. Okay, now stay with me. So when I graph this, okay, 1, 2, 2, 4, 3, 6, negative 1, negative 2, yeah, negative 3, negative 6. Okay, so we have this graph, and so basically what we're seeing is we literally can do this forever.
Yeah.
So either way, it shows us the same thing.
Mm-hmm.
We're always going to have all real numbers, okay? Now, it does get a little bit harder, so I'm going to show you, for example, let's look at this next one. Okay, here's what it says. If f of x equals 3, again, remember my rule, y equals 3. So, if y is 3, always, then let's just try any other number. 1, 2, 3, 4. Okay? 1, and then 3. 2, and then 3. 3, and then 3, and 4, and then 3. And I could even do a negative 5. Negative 5, and 3. Okay, what do you see is happening?
Straight line.
Okay, so if it says if f of x equals 3, then it wants us to find the domain and range of this. Okay, domain is all the x's, right?
Mm-hmm.
Range is all the y's. Okay.
So we know the y.
We know the y is not anything except
3.
3. So what you're going to answer on this one is, the answer would just be 3.
Would we put all numbers for D?
And then all real numbers for D, because we literally can put any number in here.
Yeah.
So domain is x's, so we can put any number in here, so we put all real numbers.
You have to use 3.
But for range, that's just the y's. And as you can see, no matter what we do, the y has to be 3.
Mm-hmm.
So the range is only just 3.
Mm-hmm.
So that's the difference.
Yep.
See that? Okay, so it helps me a lot changing this to a y. Don't know if that's actually okay to do, but it turns out right every time I do it. Just, I know that's not good math lesson teaching, but this is just the realness of it. Okay? Alright, let's try another one. Here's the next one. Alright. stupid. Okay, here we go. If the graph of the function is as shown, determine the domain and range. Okay, so here what we've got. I'm going to try to draw this. Okay? -2, +3, and then we've got 1, 2, 3, 4. Okay, this is important. So this one goes a dot here, and then we have a line that goes up to here and here. Okay? And then we have a dot that goes on the 3 to the 4, which is a dot here. Okay, that's the thing that is shown. And they want to know this. If the graph of the function, I'm going to turn the lights a little bit better. Hopefully it doesn't mess everything up. Okay, here we go. If the graph of the function f is shown, determine the domain and the range of f. Now, okay, so basically, this is our chart. So let's talk about the x's. Okay, sorry about that, my dog was barking. Okay, so remember, domain is x's, and I'm just gonna put x's like that. Okay, and range is y's. Okay, now, so we're just looking at the x's. Okay, so on this scale, how far does this go?
It goes to -2.
Okay, so x is greater than -2, right?
Less than -3.
Okay, so it's greater than -2. Does it equal -2?
Yes.
No,
I mean, no,
it's an open circle.
It's open.
Okay, so we don't put equal to, remember? Okay, so x is greater than -2, but it is less than
-3.
+3.
Or +3.
And then x is less than or equal to, because it's filled in,
+3.
+3. Okay, so what are all our x's? X is greater than -2, x is less than -3. So I write that all out with the x in the middle. So since this is x is greater than -2, I'm going to put x is greater than -2. See how this is greater than?
Yeah.
X is greater than -2,
Less
x
than
is
or
greater
equal
than -2, and x is less than or equal to 3. So this is the fullness of this picture. Got it?
Yes.
So my domain is this.
Yes.
Got it? Now, they have one more thing they want to write when they do this, so I'm going to show you what that is in just a minute. But let's go on and answer for our y. Okay? So what does this tell me my y's are? Y is
greater than 0.
Greater than 0.
But less.
Okay, wait. So I'm going to put my r down here. R is my y's. Okay? It is, y is greater than or equal to
Close circle.
0.
Yes.
Okay? But it is, what's as high as it goes?
4.
4. But y is less than
or equal to 4.
Or equal to 4.
Yes.
So when we write that out with the y in the middle, y is greater than or equal to 0, greater than or equal, see the y is greater than or equal to 0, but y is less than or equal to 4. Do you see how I do that?
Yes.
I just look and see the y right here, and it has the open spot. See that open?
Yes.
So I put y here with the open against the y. And then I know I'm doing it right. Okay? So this is my r. This. Okay? Now, they tell me one more thing. So how the book wants you to write it is the domain of f is, and then they write it like this. X is a part of, and then they've got this r, which means real number, and they've got this little thing like that. X's are a part of real numbers, and then it's got this line, such that, and then they have this written beside it. So they tell me X is a part of the real numbers, such that, this is the clear indications.
Yeah, and they do the other squiggly thing.
Then they finish off with the squiggly.
Okay.
Then on the y one is they say y is a part of real numbers such that
Yeah.
0 is less than and equal to y is less than or equal to 4. And then they end with squiggly. So they have this in front of them every time to answer it. Alright, you feel like you understand it?
Yes.
Now this is when it gets really hard. This next one is way hard. Okay, so stay with me. Here's what it says. Find the domain. Find the domain of the function f of x when it equals square root of 5 minus x. Okay? Now, here's what they want to do. So stay with me. If, I'm going to do an XY chart. If my x is a 1, if I were to put a 1 in here, I would get a 4, and what is the square root of 4? 2. That works.
Yes.
Okay? If I put 4, I'm just trying some different ones. 5 minus 4 is 1. Square root of 1 is 1. So when my x is 4,
y is 1.
Okay? When I do a 5 minus 5 is 0, and you actually do square root of 0, it's going to be 0.
Yeah.
Okay? But, what if I did 6?
-1.
You cannot have a negative inside of a something times something will never eat a -1, because if I use a -1, a -1 times a -1, which is what square root means, it'll give you a positive answer.
Yes.
So you cannot ever come up with a negative in this when you're doing square
So
root.
use something less than 5.
So 6 does not work. Does not work.
Yeah.
So what's that tell us?
Has to be a 3 or 2.
It has to be 5
Or below.
or below. Okay? So the way they write this is this. Okay, well, that did matter. -1 wouldn't work, would it?
No.
Oh, wait. Why would it equal -1? So, a negative number, anything that would give us a negative number answer will not work. So basically what they're saying is this. X is less than or equal to 5.
Yes.
Because this is our x. X has to be equal to 5 or less than 5 for this to work. 6 or even 7, if I'd have chose 7. 5 minus 7 would have given us a -2. Again, we have a negative number. Can't do a negative. So the answer has to be 5 or below to get this.
Yes.
So the way they answer that is x is a part of real numbers. I think that's just what they write on every one of them. Such that x is less than or equal to 5. Done. Make sense?
Yep.
Kind of hard. Last one. We're done. Last one. Find the domain. Again, we've got a domain. G of x equals 1 over x. So they're just wanting us to find the domain. Domain are all the x's. Okay? Let's just pretend my x is a 1. My y is going to be a 1.
Yes.
My x is a 2. It's going to be 1/2. My x is a 3. It's going to be 1/3. My x is a 4. It's going to be 1/4. Okay, so I can keep going on and on and on and on. But if x is 0,
It's going to be.
you cannot ever divide by 0. It's an error. It's impossible to divide by 0. So what they want you to write on this one is, you would say this. X is a part of real numbers such that x cannot equal 0. And that's how they do it. They tell it that x is a part of real numbers, but x cannot equal 0.
Anything except 0.
Okay?
Yeah.
And that's that. Lesson 82.